Hello class, welcome to week 7 of Programming Logic with Python. So this week we're going to be learning about object-oriented programming. So object-oriented programming essentially just like provides us a way of taking the properties of something and the behaviors of something and essentially just putting it together into like one basket or object as they call it in Python. So an example of this can be like I guess like a person. Like a person has the properties of like a name, an age, like their height, and then they also have like behaviors. And those behaviors being like they eat, they talk, they sleep. Those are all behaviors that a person might do. Um, so if we take all that into account, then object-oriented programming is really just like a way of handling real-world data and then kind of like implementing it into our code in a way that kind of like makes sense. Um, so in the past, we've dealt with like when we handle data, we kind of like use data types such as like integer, float, string, and so forth. And that was really just to kind of handle simplistic data. But when it comes to more complex data, like real world things, so like whether it's like a person, whether it's like a desk, a computer, and so forth, all of that can't really be described using integer numbers or float or like decimals or even strings. Like that's not enough. So that's kind of why we use object-oriented programming because it allows us to kind of like take the properties of something and the actions or behaviors of something and kind of like use all of that to describe just one singular thing, which is an object. Okay, so how do we implement object-oriented programming? Well, we start by using a class. So a class is basically just like a user-defined data structure. So a class defines functions called methods. And when I say functions, I mean the same functions that we learned in previous weeks. Like it started with the keyword of def, and then like the name of the function, colons, and then the body of the function. Same thing. The only difference is we're placing that function inside of a class, and when we place it inside of a class, it now has a different name called a method. So just keep that in mind. So the role of the method inside of a class is to identify the behaviors or actions of an object that is being created from a class. So in this case, the stuff we're working with right here is the class of dog, which stores information about the characteristics and behaviors of what an individual dog may have. So in that case, a class is essentially like a blueprint. It doesn't actually contain any real data, but it contains a lot of placeholders where real data will go eventually. And when I say real data being placed there eventually, I mean when a object is created from that class, which I briefly mentioned before. Um, so if we know this, then like the dog class specifies that like a name and an age are necessary when defining a dog. And obviously there's more stuff like more attributes, more descriptions that are associated with dog, but we're just going to use name and age for now. But there's no specific information for that. Like there's no specific name, there's no specific age being given yet. That comes later on. So an instance is an object that is built from a class. And when I say instance, I just mean object. They're interchangeable words. And an object actually stores the real data. So an instance of the dog class no longer becomes a blueprint anymore because it's an actual dog with an actual name and age. So all classes start with the keyword of class, and then they're followed by the class name. In this case, our class name is dog, and then it has a colon after that. Um, so if we want to add stuff in here, we should probably start by defining some of the properties. And when I say properties, I just mean attributes. They're interchangeable words as well that all dog objects should have. Because this is our blueprint, so let's start with like describing what a dog will have. Um, so there's a lot of properties that we could give them, but we're just going to stick with name and age. So the properties that we're going to define this dog actually go into two different places, the class attributes and the instance attributes. And we're actually going to start with describing the instance attributes first because I think that's the easiest way of explaining it. The attributes that all dog objects must have are actually all placed inside of a special method that we call the init method. And you guys can see that right here, so def init. And this init method is actually like, it's really important, and you actually can't, you could, but you typically shouldn't create a class without an init method defined inside of it. So this init method serves one purpose and one purpose really only, and that's to initialize the attributes for all objects that we create. So anytime you create an object, the object gets passed through this init method, and all of the attributes inside of the init method um, get assigned values for that are specific to that object itself. So that's kind of why I put name and age here, because name and age are going to be dynamic attributes that are going to change with every object that we create for this dog class. So one dog might have one name and another dog might have another name. Same with age. So that's kind of why I placed those there. Now you might be thinking to yourself, okay, well, if that kind of makes sense. Well, what's up with this self parameter that you included after the init name? So actually, before I get to that, what the init name for this function, because it's a special function, you can't change the init name, so it's always going to be def underscore underscore init underscore underscore. So that will never change. Open parenthesis self. So self is also pretty important. Um, Anytime you declare a method, and this is a method, even though it's the initializer method for our class, it's still a method. So anytime you declare a method inside of a class, that method must always have one, at least one parameter, and it must be the first parameter always, and that must be the self parameter. So that's why I included self here. So this self parameter is super important because anytime you create the object name itself gets passed through the self parameter as an argument. And it does that just because it knows that anything inside of this init method is dynamically going to be different for every object that's created. So that's why the object name gets passed as the argument. Um, so the other stuff, the other two, name and age, we already talked about it. Those are just um, attributes that we believe are descriptions for all dogs, descriptions that are kind of necessary, but we just don't know what they are yet. So let's move on to the class attribute. The class attribute is really just, it's more of the static version of the attribute. So that's why I created a variable called species, and I assigned it a value of Canis familiaris, because that just means that they're all dogs. So this class attribute automatically gets assigned to all objects of this class. So that's kind of why I didn't have to include it inside of the init function, because when you include an attribute outside of the init function, it automatically is just referenced as the class attribute. So that's kind of the difference between the two. The class attribute is static. That just means that whatever you put there, you just want to be applied to all objects of the class. And then anything you put in, any attributes you put inside of the init function or the init method are dynamic stuff that you think that, yeah, they're necessary for whatever object you're trying to, or whatever class you're putting them inside of. But, you know, like the values will change. So that's kind of what's happening there. Whew. Okay, so let's kind of get into, I'm not going to get into these regular methods yet. We will get into them in a second, so just ignore them for now. Let's get into how to create an object. Now that I've talked about what an object is so much, an object is basically just like, uh, it's a instance of a class. I think that's the easiest way of saying it. When you create a new object of a class, you're essentially instantiating that object. You're instantiating an object of that particular class. So when you instantiate a new object by typing like the class name of dog, So as I've done here, so here I've created, there's a lot of different ways you can do this, but I think the easiest way, the simplest way is just doing create a new variable, and that variable is going to be like obviously whatever you want it, and that variable becomes your object of that class. So here my object that I created is dog1, and then I equated it the value of the class. So this is the syntax you kind of have to follow. So um, whatever the class name is, just include it here. And once you do that, that dog1 becomes an object of the dog class. And then these two arguments that I passed inside the parentheses are just really, I included them because I know that once I create this object, it has to run through the init function. So because I know it has to run through the init function, I do have to satisfy these three parameters. So because I already know dog1 is going to take the place of self just by default, anytime you create an object, it's always going to be like that. I do have to satisfy these other two parameters. So in order to do that, I know this first one is name, so I'm just going to pass buddy because that's what I want the name to be. And then for age, I'm just going to pass 9 because that's what I want the value associated to the parameter of age to be. So that's really what's happening there. Very simplistic, very straightforward. So now that I instantiated the object, it gets saved in memory. So if I were to just like print out just this code right here, nothing's going to come out because all I did was give it a blueprint, create an object, and nothing else. Nothing gets printed out to the console. If I wanted to print something to the console, then I would have to do print dog1. And if I wanted to just print out like something like specific, so like if I just wanted to print out like a specific attribute for dog1, I would use the dot notation. And dot notation is basically, it's very similar to the method method syntax that we've learned in previous weeks. But it's a little bit different because it's not the method notation, it's dot notation. So it's just your object name, in my case it's dog1, period, and then the attribute that you're trying to get the value of. So in this case, I'm trying to get the value of name associated with the object of dog1. So what do you guys think that's going to be? Because I'm not going to print this out because it's relatively straightforward. It's going to be buddy. Buddy is what's going to be printed out. Now, if I did this for dog1 period species, species, while it's not a instance attribute, it's a class attribute. And it doesn't matter if it's a class attribute or instance attribute, I could use a dot notation for either one to pull its value to double check my work. So that's what's happening here. So if I do that, if I do dog1 period species, what do you think gets printed out? Well, Canis familiaris is what's going to be printed out because that's what's associated automatically to dog1 because it's a class attribute. Okay, so same with age, it's going to be 9. I don't think I have to explain that. But what if you wanted to know, like say you create the object of dog1 for the class of dog, but say you're not sure, like say a year goes by and then you're like, oh man, there's this object of dog1, but I don't remember what class I assigned it to. For that, you could just use the type function. As we've been doing before, just do print type and then put dog1 inside of it. And then when you print this out, Python's going to say, okay, well, we believe this class is from the class of dog. Very straightforward, very simple. Okay, so now that you guys understand that, what if we wanted to change the value associated with a specific class attribute? Or not class attribute. Well, yeah, it's technically a class instance attribute. So like age. Age is an instance attribute from the class of dog. So if I wanted to change the age for my object of dog1, all I would do is, well, obviously I did this in the print statement. I would do print dog1 period age, or actually no, hold on, I got ahead of myself, sorry. A dog1 period age equals 12. So I'm changing the value of age from 9 to 12. And then I'm printing out the new value of dog1 period age. Yeah, okay, so that makes more sense. Same thing for dog1 period species. So you can do it not just for instance attributes like changing their values, but you could also do it for the class attribute, which was originally a static value, but you could technically change it if you want. Most people don't do that because it's supposed to be a static value, but you do have the right to do it if you wanted to. So one last thing I do want to go over are these regular methods, which I said we were going to skip over for the time period, but now it's time. So these regular methods are regular methods. So this def init method is a special method. It's the initializer for every new object, but these regular methods are not initializers. These are just regular methods that are called upon, that are not called upon. They're executed when they're called upon. So they act very similar to regular functions. Because remember, a method is a function. So they act very similar to regular functions in that, yes, they're there, they exist, but they only really execute their return when you call them. So the way you call them is by associating them with a specific object. So since I only have one object right here of dog1, I'm just going to include this in my print statement. You do print, and then you do dog1 period, and then let's use the method of description. So I do dog1 period description, but description actually technically doesn't really have any argument or parameters. It has this self parameter, but if you remember, I said self parameter is necessary. It doesn't really take in an argument, it takes in the object name as its argument. So dog1 is actually the argument being passed through self, which doesn't really do anything. It just says, okay, it basically just allows you to call the method um, in association with the object. So what's really going to happen when I print this out is it's going to say, okay, well, it's returning self name, which is for dog1 Buddy. So Buddy is, and then self age, which is 9. So Buddy is 9 years old. That's really all that's going to be printed out when I call this method of description. And then for speak, now speak, I did pass one argument of wolf wolf. Okay, so let's look at this second method up here that's inside of my class. So this second method is the speak method. Now, obviously it has that first self parameter, but that second parameter is sound. And sound, I didn't really have a argument. Well, I do have an argument that I'm passing through. That's wolf wolf. Uh, self, the thing that's going to take the place of self is dog1, and then wolf wolf is going to take the place of sound. So when this argument gets, or when this print statement gets executed, when it's calling this method, it's actually going to print out Buddy says wolf wolf, because that's the argument that's taking the place of sound. So hopefully that makes sense. It's just basically a review of basic functions, but being implemented in classes. So yeah, that is the most basic implementation of a class and creating an object from that class, and that's essentially object-oriented programming. Now there is one more step that I do want to take, and that is inheritance. And inheritance is essentially what it sounds like. We're inheriting from something, and I'll kind of explain what I mean by that. So inheritance is essentially the process by which one class takes on the attributes and methods of another class. So a newly formed class, so like newly formed class of Jack Russell, this dog breed, and then Bulldog, are inheriting from the original class of dog. So all of the class attributes, all of the instance attributes, and all of the regular methods are all being carried over into these new classes that I created. And you might be thinking to yourself, okay, well, I guess that makes sense, but how do we know the difference between a child class from a parent class? Well, if you notice the syntax of the parent class, it's just class and then the name of the class. But for these three child classes that I created, it starts with class, then the name of the class, but then we have open and close parentheses, and inside of those, we have the name of the parent class. And for all of these three child classes, all three child classes are inheriting from the same parent class of dog, meaning that they're all taking all of those attributes and all of those regular methods from the dog class as their own. And why would they want to do that? Well, they essentially do this just to like save time because we want to be able to reuse code because even though these are like different breeds of dogs, they're still dogs at the end of the day. So they still inherit the basics of what a dog is. Like a dog will have a name, a dog will have an age, a dog will have a species. But now a child class, why we would create child classes, certain breeds of dogs have specific characteristics that are specific to their breed themselves. So that's maybe why we would want to inherit from or create a separate class that inherits from the parent class. Now, I do have some examples here. So these two child classes are empty. I'm not going to touch them. But this one Jack Russell Terrier class, I do have some code inside of here. And this code, if you actually were paying attention, this code is a method. The reason I don't have to include the init method here is because I'm already inheriting the init method from the parent class. So you could include another init method, but you don't have to. I guess that's the point. But this is just a regular method here. This is the def speak method. But if we pay attention, if we go all the way up to the parent class of dog, we also have another def speak method there. So it's the same method name. And if you remember from functions, like we can't really have two functions of the same name. So why are we allowed to have two methods of the same name here? Well, technically they're different classes. So there's no conflict there, but because they're the same name and the child's inheriting from the parent, what ends up happening is the child's speak method overrides the parent's speak method. So the child speak method gets executed when I create an object from the child class. So let's do that. So let's create an object from actually there's really no point in doing this. Just I don't want to confuse anyone. So let's do dog2. And let me just change some code around. Dog2 name, species, speak. Okay. I'm just making sure everything is how I wanted it to be. Type. Actually, I should probably do it within print statements, just because that's what makes sense. Do dog2 different type dog1. And then this is, we'll get to that. Okay, so yes, I created these three child classes that are inheriting from the parent dog class, but I'm really just going to deal with the Jack Russell Terrier child class for this example. So first, if I want to really just like show you examples of how a child class can override the parent class's method, first I have to create an object for the child class. So that's exactly what I'm going to do right here. So I created the object of dog2, but this dog2 object pertains to the Jack Russell Terrier child class. So it technically is an object of this class, so I could technically just do dog1 equals Jack Russell Terrier, because it's an object that belongs to that class, this child class, not the parent class of dog. So dog1 for the parent class is not the same as dog1 for the Jack Russell Terrier class, so do keep that in mind, but just for sanity's sake, I'll just call this dog2. Okay, so let's see. So if I wanted to print out the species of now this newly formed object of the Jack Russell Terrier child class, I can do dog2 period species, and it would print out the species of Canis familiaris, because that's the species that's being inherited from the dog class, and it's not being overridden by anything here. If I wanted to, I could technically, actually I'm not going to even get into that. If you want, you could play around with that, but as it is right now, it's inheriting from the parent class. Now, if I do dog2 period name, now that name is actually going to be Miles because that's what's being run through the init function or the init method from the parent class as well. So it's being run through here, and it's asking for name, self period name, and then the name that I'm assigning it is Miles, and same with age 4. So that's what's being printed out there. Okay, so now let's look at this print statement right here. So dog 2 period speak, and I'm passing the, actually let's not even pass an argument here, because why would we? Actually, we could pass an argument. No, let's not pass an argument. And then I can get rid of this. I'll get rid of this too. I don't want to confuse you guys with this. Okay, so the way we get this method, the speak method, to override the parent class's method is just by not passing an argument. And also because well, it doesn't matter if you pass an argument actually, because I can just say, how do I show you? Let's do child, child class. Child class. Okay. So actually I will run this. Perfect. Okay, now you guys can't see the code. So I'm gonna remove that for a second. Okay. So this def speak method in the child class is gonna override the parent class regardless. Whether I include an argument here or not, it's gonna override it regardless. And the way I can prove it is just by like including this child class before this self name says sound. Because the differences between the self method right here and the child class and then the parent class is not just, well, actually the only difference is this. In the child class, I'm actually giving it a default argument. So yes, I gave it, or default parameter argument. So the parameter is still sound in both of them, but here in the child class, I'm assigning sound, like the parameter sound, a value of arf. So if I were to do dog 2 period speak, it would use this method, and because I didn't pass a argument, it would just use arf. And if I run this, that's exactly what you're going to see right here. So child class hyphen Miles says arf. Now, if I were to actually give it a value, so like let's say a dog doesn't say boo, but I can't think of anything right now. It still says child class, which means it's still using that the method from the child class because it's overriding the parent classes, but now it's taking in my argument of boo, so now it's saying Miles says boo. So that's kind of what I wanted to prove, just so you guys don't get confused. It doesn't matter if you include an argument or not. If a method in the child class has the same name as a method in the parent class, the child class's method will always override the parent class's method. Now, there is a way of getting even with the same name of like if I had def speak in both the child and parent class, if for whatever reason I wanted to still use the parent class's def speak, there is a way of doing so using the super function. But the super function, I'll probably include that in the coding packet, but I don't want to confuse you guys. And I also did want to kind of keep this video short because there's a lot to cover when it comes to object-oriented programming, but I feel like this is enough of a foundation for you guys. And then there is a bunch of other extra stuff like the super function and so forth, and encapsulation and polymorphism. But I think inheritance is good enough. So inheritance, so yeah, what we went over in this class or in this video was classes, attributes, methods, or yeah, attributes, methods, the init function, or the init method, how to create an object, how to access values from an object, inheritance, how to create an object for a child class, and then how to access values and how to change, yeah, how to access values for the object from a child class. Yeah. Okay, so that was basically what we covered in this video. It was a lot in my opinion, but I tried to go through it as precisely as I could. just so I didn't confuse you guys, and hopefully I didn't confuse you guys. But all the extra stuff that might be included in the book and that I'll probably include in the coding packet, that stuff will just be in the coding packet. I don't want to overload this video with that stuff. But yeah, that's it. So that's week 7. I think this is a good starting point for you guys. You'll build on it. It's a huge subject in general, object-oriented programming. It's really not possible for me to throw every ounce of information on this topic in one video because the video would be way too long. So that's why I wanted to keep it nice and short, nice and precise, um, and hopefully it was useful as a starting point. Obviously, ask me questions throughout the week through Slack and everything, and I'll answer your questions, obviously, and give you an explanation. But as long as you understand this, everything else is just built upon it. Just understand what a method is. Understand what the init method is. The init method is a special method, super important. It initializes all your objects. Understand what a regular method is. Understand inheritance, why we use inheritance, so forth. If you understand that, everything else will take time, but will make sense. So yeah, I just wanted to end it there. I think we're like, what, 32 minutes? I think that's a good stopping point. Probably the shortest video of the semester on the hardest topic, but it was for a reason. If I made it any longer, you guys would get really confused. So nice and short, nice and precise. So yeah, I won't see you guys next week, but if you guys do stick around for week 8, which is not a part of the semester, like I said, I will be posting the first video of algorithms using Python as a base. So if you are interested in that, you guys can watch it. It will be uploaded next week, next Monday. Yeah, if you guys are interested, it's not mandatory or anything. I did explain it in week 6 video, like at the end of the week 6 video. So if you guys do want an explanation on that, you guys could reference that. So yeah, I'll see you guys then if you want to stick around. If not, it's cool. All right, I'll see you guys.